Okay, dear students, chapter number 26, Physics for Scientists and Engineers, Giancoli. Charter name is Giancoli. So this is parallel combination of resistors. So parallel combination, so that we connect each resistor left end with the same terminal. So simply we connect left end with the same point A of R1, R2 and R3, and this point is connected to the positive terminal of the battery, and the right end of these points are connected to the point B, and this point is connected to the negative terminal. So these are parallel combination of the resistors. Okay, in the previous lesson we discussed about the series. In the series we connect R1, R2, R3 like that, the end to end connector, but this is not end to end. On the left end are connected to the same potential, right end are connected to the same potential. Okay, so for the parallel combination, the total equivalent resistance formula for total equivalent resistance is equal to 1 over R equivalent to 1 over R1 plus 1 over R2 plus 1 over R3. Now we have to derive this formula, we have to prove this formula. In order to prove or derive this formula, we know that the total voltage V is V, for example. Now the current starts flowing through the battery. Now the current I starts flowing through the battery. When this current flows through the battery, it reaches at point A, for example. Then there are three branches, you can see that. So I1 current flows through the resistor R1. So the total current is divided into R1, R2 and I1, I2 and I3. So there are three currents that flows through three resistors. And then when they pass through and they reach at point B, they again meet and become the same total current I, and then total current I reaches the battery again. So you can say that, suppose that if for example 10 ampere current is flowing through the battery, living through the battery. So at point A, that current is 10 ampere. Now if the resistance R1, R2, R3 are the same, so the 3 ampere is flow through the R1, 3 ampere is flow through R2, 3 ampere is flow through R3. So when R1 reaches at point B, R2 and R3, mean the current I1, I2, I3 reaches at point B, they again recombine and it will give us again 10 ampere, and finally it reaches towards the battery. Okay, now it does mean the current I is equal to I1 plus I2 plus I3, because we know that R1, R2, R3 are different. So you can say that it is not exactly equal to 3 ampere because the three resistors are different. So the total current I is divided into three branch currents. Okay, now one thing, another thing is that the voltage developed across R1, R2 and R3 are the same, because we know that the R1 left end is connected to the same point A, because all ends are connected to the point A. So A point, for all ends the point is same point. So it means the for the battery to displace, to perform work done from this positive terminal to point A is same, because for all points are connected to the same potential. In other words, we can say that the left end is connected to the same potential and the right end are connected to the same potential. It means that potential V1, V2 and V3 are same. So we can say that in this case the current divides, I is equal to I1, I2, I3, but potential does not divide. V1 is equal to V2 is equal to V3 is equal to V. Okay, now from 1 we can write I is equal to, as we know that Ohm's law says that according to Ohm's law, I1 is equal to V1 over R1, but instead of V1 we can write a V, simply because we know that the V1, V2, V3 are same. No need to write V1, V2, V3, only V. I2 is equal to V over R2 and I3 is equal to V over R3. Now we put this value in equation 1, we get I is equal to V over R equivalent total current, and then V over R1 plus V over R2 plus V over R3. So we know that the V's, we can take V common, so V over R equivalent or total equal to V 1 over R1 plus 1 over R2 plus 1 over R3. Now V will be cancelled, so 1 over R equivalent or total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is the total resistance for parallel combination. I hope it will work. So I again repeat, the voltage across resistors R1, R2 is the same. because the same amount of work is performed by the battery to develop the charge, to move the charge from positive terminal to point A or toward the left end of these resistors, and the right end is the same thing. So that the V1, V2, V3 are same, the same potential, they develop the same potential, but the current is divided into I is divided into 3 branch currents, I1, I2, I3. So the total current I is equal to I1, I2, I3, and then we have to put I1, I2, I3 by Ohm's law, then we can find the resistance, total resistance R equivalent. Okay, so we can just put these values in this resistors if we have different resistance, so that the total combined or equivalent resistance of all these combination is equal to R equivalent resistance. Okay, so we can find R equivalent and then we can find current or voltage, anything from this formula. Okay, thank you.